Greetings! Here's an arcade game from 1980, a Cinematronics ripoff. This game was generously donated to the channel by David Youngberg, and it has an interesting backstory. The original owner of this had it for years, and then one day it died and emitted magic smoke. He tried to get rid of it, and as he was moving it, I guess, within his property, going down a few railroad ties acting as stairs, he couldn't do it anymore and kind of just left it there. I mean, I've been told this story. I saw some pictures of it, and it was conveniently sitting not far from a ravine, so a few kicks could have made this a permanent fixture of the Utah landscape. But fortunately, David went out there, rescued it just before a snowstorm, and donated it to me. So to do justice to David's efforts, let's fix this thing. I stuck my head into the back of the cabinet and just smelled, and the magic smoke smell seemed to come directly from this power supply. Power supply is mounted a good distance away from all other electronics, so it was pretty clear that something had happened here. And that, of course, was my big hope, because this is a vector game and it has a proprietary chassis to drive the vector tube. And if that goes bad, parts for that would probably be very difficult to find. I mean, I don't know yet. They both may be dead. But for the past few minutes, I brought this thing down, and I was happily babbling while taking it apart and observing it and everything. And then I discovered that the camera wasn't on. So that's why we have a bit of a discontinuity here. But I'll explain what I found so far and what we're going to do with this. It's a run-of-the-mill power supply, linear in nature. Remember, this is 1980. Big caps with bleeder resistors on them. The transformer itself, which shows a bit of discoloration, but I am sincerely hoping that, well, that this is not the problem, because this is going to be difficult to replace. Here's the main PCB with a few parts missing that I've already taken out. And it's got two real fuses and two resettable fuses over here. These are mostly here for the when the monitor starts drawing too much power, I think. These will pop, but they're resettable because I guess that's something that may happen somewhat frequently. I don't know, it's just a guess. But let's have a look at the parts that I pulled, purely based on a visual inspection. First thing that caught my attention was this 10,000 microfarad capacitor, which seems to have grown a pot belly, and what looks like an incontinence problem is not that, because that's some sort of a goop they used to stabilize, to glue things to the PCB. As I took it off, all of its wrappings fell off. They are fried. This thing got really, really hot. So let's have a look at what this cap's telling us. And it's going to take a while, because, well, it's supposed to be 10,000 microfarads, except that this got tested at 256 microfarads with a loss of 31% and an ESR of 34 ohms. So essentially this was acting as a power resistor with a resistance of 34 ohms, and thus gave up its life. And I think when you replace a smoothing cap with a resistor, strange things will begin to happen. So here's candidate number 1. But I don't think this emitted smoke. So I had to go on looking. And what I additionally found, I was a rectifying diode in 2 pieces. And that smelled pretty badly. So, I mean, I don't know if that can create that much bad smell, but obviously this one's bad. Its companion is next to it, and it looks okay physically, but it measures open. So far, basically I found 2 bad diodes and a bad capacitor. I pulled some other components. For instance, here's a series pass transistor. Note the date code was like what? That's like what? July of 1980. But this tested good. It got identified correctly by the tester, so I'm assuming it's still good. If it lasted this long, sure. So let's see. Well, let's clean up. These basically came off of the small PCB that's on here, and that I started to work on. So what I'm going to do is clean out solder from holes, put new components in there, if I have them, measure a few more things, but the stuff I showed you is reason enough for this thing to emit magic smoke. These components were all in the regulated 5-volt supply. So yes, the board obviously didn't run. But once I have everything replaced, we'll put it on the variac, bring it up slowly, and see if it's starting to create the voltages that it should. Everything's put back together. Plugs are back in. From what you can see, the PCB is back in. It was an interesting exercise getting this mounted because, well, the board mounted, because it uses the 2 screws that hold in the transistor to hold the whole board in. And there's 3 million washers and spacers and stuff in between, but looks like it's stable and nothing's touching the case. So now it's time to figure out how to get AC into this and see if we fixed it. And now for the big test. First thing we're going to measure is 5 volts, because all of the components we changed were in the 5-volt section. So 5 volt comes out of pin 9 and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll go into 9. And the 5-volt ground is at 11. 10, 11. Alright, boys and girls, don't try this at home. Yes, I know this is not an ideal setup, but I got things taped down. I triple checked them. Nothing's touching where it shouldn't touch. And okay, so now I am going to turn the variac down to 0, power it up, and start slowly increasing the input voltage. 10, 20, 30, 40, 50, that's the AC volts coming in, 60, so it looks like it's regulating at 60. I mean, the voltage is going to be higher than 5 volts because they're line losses. I haven't touched the adjustment on it yet. But let's see, we're sitting at 60 volts in, 70, 80, 90, 100. It's in full regulation. Yes, there's no load on it, but at least I didn't mess up totally when I changed those components. And now we crank it all the way to 120. And it's still regulating. There is no smoke, there is no smell, and everything seems great. Next we have a bipolar 25 volt DC coming out, and first we're going to measure the positive side. The variac still set to 220 volts AC, and it's off. Here it goes. So this is 25 volts DC, but of course it has the big unregulated disclaimer next to it, which basically means that the base number is usually totally off. This is actually pretty close to 25 volts, plus 25 volts unregulated. That's good. So now we go to minus 25 volts regulated, which is on pin 8. 6, 7, 8. Oh, we're still seeing some negative voltage bleeding off. Turning on the variac. Oh, it's pretty close to perfectly symmetrical. This is minus 25 volts DC unregulated. Again, we have no load on this, but so far, so good. And our final voltage is 6.3 volts AC. I've already plugged it in. Yeah, we're all set up. We are still on 120 volts with the power off, and here it goes. That's more than close enough. We got 6.8 volts AC coming out of the specified 6.3 volts AC outputs. Power supply seems to be working. So next we got to go to the acid test, reinstall this in the cabinet, and see if anything happens. Hooray! Two more points of interest. One is I replaced the 10,000 microfarad cap, smoothing cap, but I didn't have a 10,000 microfarad. All I had was a 4700 microfarad. I'll have to order a 10, but I put it back on, and let's see what the ripple is. And again, there's no load on it, but let's make sure that the ripple isn't too high. And as we can see, at least in this situation, that cap is working perfectly. Second thing is, remember I removed that one diode that was broken apart. The other one looked fine but measured open. Well, of course I pulled it out to replace it, and here's what we ended up with. Come on. Thank you. So as I desoldered one end of it, that end fell out and the other end stayed in. So the second one was also badly affected by whatever caused its ills. So definite confirmation of that everything that got replaced was defective. I remounted the power supply in the cabinet. We then have the CPU board over here and the soundboard right above it. Now, looking at the CPU board, At first I thought there was something missing. And if you think you can find it, stop the video and have a look. But I noticed I couldn't see a CPU chip. Nothing resembling a CPU. So I said, what, am I missing a board here? Long story short, I finally looked at the schematics. This is the CPU you're looking at, and it's built out of discrete. So it's got ROMs and RAM and a whole bunch of TTL on it. But for our initial test, I went and I unplugged power and the data cable from the monitor, basically do an initial blind test. Now there is an LED on the board. Let's see. If I can get this out of the way, which is right here. And that's supposed to flash one time when you're turning it on, and that means everything's working. So, here we go. Okay, no smoke, loud fan, and it blinked once. So let's go and see if we can coin up the game and play it blind. Alright, let's coin her up. Yep, well, the counter clicked, so something is alive. Obviously the monitor's dead, but let's do a one-player start. Well, it's making firing sounds. It seems to be playing blind, which is great because we fixed the 5-volt supply, and so the CPU board with the discrete, with the CPU built out of discretes is working, and that's probably the biggest hurdle. So now let me plug in the monitor. I plugged in the monitor. The neck lights up. That doesn't mean a whole lot because that's just being fed by the 6.3 volts AC. But I heard one, if not both, of the resettable fuses, guys with the red buttons on it, pop. That is the unregulated plus minus 25. I gotta find out which one popped, see if anything happens. This may be not a very wise thing to do, but I'm gonna do it anyway. Okay, that one was definitely gone. That wasn't. So it's the one click. That one goes, that one trips, that one stays on for a while, and click, that one went off too. So both of the unregulated 25 volt supplies, when plugged into the monitor, trip. And I guess we'll need to have a look at the monitor. So one last test was that I turned off the machine and made sure that both of these fuses were reset. And let's see if you can hear it. 3, 2, 1, go. So something happened. That was the second breaker going. But that noise you heard was we briefly got vector chatter coming out of the monitor. And what that means is vector monitors, the chassis, are actually kind of noisy. You can hear the different coordinates for the vector beam coming in, and that's called vector chatter. We very briefly heard vector chatter there before it blew first to plus 25 and then the minus 25. So we obviously need to work on the monitor. Well, that concludes part number 1. We fixed the 5-volt section of the power supply, verified the other sections, and saw the CPU board come up. It seemed to play blind. I mean, we don't know what it looks like. But, well, at least the CPU board's running. Plugging in the monitor caused things not to work anymore. I didn't show it on video, but the CPU board will not play blind when plugged into the monitor, and that's probably because the monitor is blowing the bipolar 25-volt lines. So we'll pull that out, have a look at the chassis, and hopefully it'll be an obvious fix, just like the power supply. Thanks for watching. Like, subscribe, etc., and we'll see you next time.